वेलकम टू आवर चैनल बी ऑलवेज लर्नर। वीडियो में हम लैपलेस ट्रांसफॉर्म की प्रॉपर्टी ट्रांसफॉर्म ऑफ इंटीग्रल्स कवर करेंगे। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए एंड डू नॉट फॉरगेट टू प्रेस द बेल आइकन टू गेट द लेटेस्ट वीडियो। द ट्रांसफॉर्म ऑफ इंटीग्रेशन जो प्रॉपर्टी है दैट इज डिफाइंड लाइक लैपलेस ट्रांसफॉर्म ऑफ इंटीग्रेशन ऑफ x tau d tau limit minus infinity to infinity the square bracket of the Laplace transform of the integral of x with the limit minus infinity to t will be governed by xs by s plus integration from minus infinity to 0 negative x tau and d tau. Complete term divided by s if x t having the Laplace transform this property is proved if this is equal to. So the proof of this proof is हमें जो टर्म गिवन है यहाँ पर that is integration of x with the limit minus infinity to infinity minus infinity to t x tau d tau का इंटीग्रेशन ये गिवन है. This limit can be bifurcated into two portions from minus infinity to 0 negative and from 0 negative to t. So that is the entire interval covered by this. So this can be written as x tau and d tau, and this is again x tau and d tau that can be. So we have to find out the Laplace transform of this. So we can write the Laplace transform of minus infinity to t limit and x tau d tau. अगर हमें इसका Laplace transform निकालना है तो that is equal to the Laplace transform of minus infinity to 0 negative and x tau and d tau. So, with the help of linearity property, we can write like this: 0 negative tau and x tau. That's how we can write it. Fine. So here we can find out the Laplace transform of this term. So by definition, we can write the Laplace transform of integration from 0 negative to t x tau d tau. So this term is directly I am writing this term. So that is equal to, by definition of Laplace transform, that is integration from 0 to infinity. Integration from 0 to infinity. The square bracket, we can have our function that is 0 negative to t and x tau d tau bracket. This is the function to be there this is by definition I can write. Fine. So again, the, in this also we are going to have the integration by parts. So the formula for integration by parts is integration u dv, that is equal to u into u minus v into integration of v with respect to u. So that is what the integration of parts, because this is equal to this. So because of that, we have to find out the value of u here, which is the internal component, that is integration o negative 0 negative to t and xt tau d tau, that is the value of u. का हम डेरिवेटिव लेंगे to find out the value of du, that is equal to x. Fine. So again we have to find out the value of dv, that is equal to outer part, that is equal to e raised to the power minus st dt, and that is equal to, or that implies that v is equal to 1 minus 1 by s e raised to the power minus. That's how we are able to find out the value of u, du, and v. Now using the integral by parts, we can have this equation, like now from this to this, and right now I'm putting the value of u and v. So it is minus 1 by s e raised to the power minus st, that is the value of v, and now the value of u, that is integration from 0 negative to t x tau and d tau. Put the limit from 0 to infinity plus 1 by s 1 by s integration from 0 to infinity x tau, or here it is xt e raised to the power minus st dt. So this is the value of this integration of v with respect to du. So this internal part of the equation is nothing but, internal part by definition is nothing but x. So I can write this second term is xs by s. So I can write this entire term like xs by. So we are getting this term. Fine. So this first term, now, this first term is vanishes, since e raised to the power minus st is approaching 0 as t tends to infinity. At lower limit, we can have the integration from 0 minus to t x tau d tau, that is equal to 0. Now I am talking about this part of it. Fine. So now we can write that the Laplace transform of integration of x tau d tau with 0 negative to t bracket close, that is equal to xs by, because this portion is lending towards 0. नाउ अगर हम थोड़ा ऊपर देखते हैं तो हमारे पास दो पोर्शन, राइट? आई एम जस्ट रीराइटिंग this term here for your convenience, that we have to find out the Laplace transform of integration of x tau d tau from minus infinity to t bracket close, that is equal to the Laplace transform of integration from minus infinity to 0 negative x tau d tau. तो प्लस, नाउ ये टर्म जो ये वाली टर्म है इसका हमने लाप्लास ट्रांसफॉर्म निकाल लिया है, दैट इज दिस टर्म और विच इज गिवन बाय एक्स स्क्वायर. So that is what we are able to find it out. Now another, that this term is a the first term we are talking about is a constant term, and the Laplace transform of constant term is multiplied by 1 by s, because हम अगर ut का Laplace transform देखें, it is also a causal constant term having the amplitude 1, so it is 1 by s. So in the same way we can do if it is a constant term, then it is integration minus infinity to 0 negative x tau d tau, and it is multiplied by, because this is a constant term, so this is multiplied by 1 and 1 is nothing but ut, so it is divided by s plus, that is x by. So this is the Laplace transform of a integral term. So hope you understand the proof. So please see the video clearly so that you are able to understand the concept. Please you subscribe the channel and like the video, share the video. Do not forget